Hello and welcome to this Python tutorial about multiple linear regression. So in the previous section we implemented simple linear regression in Python, and this time we're going to take a step forward and we're going to add some dimensions in our data set, because this time there's going to be several independent variables. In simple linear regression we had one independent variable. This time we're going to have several independent variables. Okay, so let's implement multiple linear regression on Python right now. So the first thing we need to do is, as usual, set the working directory. So we'll go to File, Explorer here. We'll go to our Machine Learning AZ folder, Part 2 Regression, Section Multiple Linear Regression, and here is the folder we want to set as working directory. Let's make sure that we have our dataset CSV file 50 startups in this folder, and if it's the case, we are ready to set this folder as working directory. So to do this, let's not forget to click on this little button here. Here we go, now it's ready. Okay, and now the first step of making our model is to prepare the data set. And so to do this, as usual, we're going to use our data preprocessing template that we made in part 1. So I'm going to copy all this, copy, and then paste it here. So that saves us a lot of time. And now what we need to do is to change a few things. So let's start with the name of the data set. That is of course not data.csv, but 50 startups. All right. And then let's have a look at the data set. But to do this, we need to import the essential libraries, and especially the pandas library, because we are importing this data set with pandas. So let's execute this. Here we go, imported well. And now let's select this line to have a look at our data set. So the data set is well imported. Now let's go to Variable Explorer to have a look at it. Let's double click on data set, and here we go. Okay, so first of all, the format is not great, so we're going to change it. So as you can see, this is the scientific notation. We will ask for no decimal by replacing 3 by 0, and we will change G into F to have floats. Okay, now it's better. All right, so what is this data set about? This data set contains informations of startups, actually of 50 startups. We have 50 observations. These informations are the R&D spend, the amount of money spent in administration, the marketing spend, the state in which the startup operates, and the profit. And the thing to understand here is that we want to build a model to see if there is some linear dependencies between all these variables, that is the R&D spend, the administration spend, marketing spend, and the state, and this variable, which is the profit. So that means that in the end, we want our model to be able to predict the profit based on these informations here: R&D spend, administration, marketing spend, and state. So that's the thing that needs to be clear in our head. These are the independent variables, and this is the dependent variables. And now that we understand that, we know what indexes to input here for our matrix of features, that is our matrix of independent variables, because simply our matrix of independent variables is going to be all this matrix from here to here, so the profit excluded, containing our 50 observations. All right, so that's the matrix. And then Y here is going to be the last column, because it's going to be the dependent variable vector. So it's going to be the vector of profits here. Okay, so now let's change the index. As I told you in the data preprocessing part, we don't need to change the thing here, because all my data sets in this course are going to be with the independent variables first, and then the dependent variable as the last column. So that's why I put a -1 here to remove this last column to take our matrix of independent variables here. All right. However, we might need to change this index here, but maybe not. Let's see. This index must be the index of the dependent variable vector, the profit column. So since indexes in Python start at 0, let's count 0, 1, 2, 3, and 4. Unfortunately, we have to change it, but it doesn't matter, right? We just need to replace 3 by 4. All right, and now it's ready. We are ready to build our matrix of independent variables x and our dependent variable vector y. Okay, so now let's select these two. Command and Control plus Enter to execute. And here we go. X and Y well created. Let's have a look. Okay, so we cannot have a look here because the type is an object. And that's because the matrix contains different types. So it cannot select a single type here. So we're going to look at it from here. X. All right, so this is our matrix of independent variables. As you can see, we clearly see the 4 independent variable columns with the R&D spend, the administration spend, marketing spend, and the state. And now let's have a look at Y. Well, actually, we can have a look from here because since it has a single type, we can have a look. Because, by the way, if I double click on this, I have this message. And that's because the type is an object. But here the type is float64. So I can click on this and I can have a look at my dependent variable vector. Okay, and these are all the profits, the real profits. We didn't make any prediction yet. So, okay, right, and we are not ready yet. Now, we need to pause for a second because when you look at this matrix of independent variables, what is striking your attention? Something must be striking your attention, especially if you followed the part 1 data preprocessing. Remember, we might need to do something here. What is it? Well, remember in part 1 data preprocessing, we talked about categorical variables that must be encoded because if they're kept as text, this might cause some issues in the machine learning model's equations. And here, as you can see, we have one categorical variable, which is the state variable, and this variable is not encoded yet. We have the strings here. We have the text New York, California, Florida. So we might have some issues in the equations. So of course we will need to encode this column here. And so we are going to do exactly the same as what we did in the data preprocessing part. We are going to use the label encoder to encode this column into numbers. But then in order to remove any relational order, we will use the one-hot encoder to create the dummy variables. So let's do this. We're going to go to File Explorer here, and then we will jump back to our previous part, which was the part 1 data preprocessing, which is here. So I'm opening the folder here. I'm opening the section folder. And here is the categorical data Python file, which we will now use to encode our categorical variable state that we have in our dataset. And you're going to see how fast this is. I will just need to open this. All right. Now I will take this code section here, copy, and then I just need to close this. And I'm going to add it here because the encoding must be done before the splitting of the dataset into the training set and the test set. Okay, so now let's encode our variable. So first, we only have one categorical variable, which is the state variable, and therefore it's an independent variable. We don't need to do any encoding of the dependent variable because it's the salary, it's not categorical. So first we will remove this part that was encoding the dependent variables. We don't need it. However, we need this part which is encoding any independent variable. And now we just need to change a few things and we will be ready to encode our independent variable state. So the first thing that we need to change is actually the index of the column we want to encode. So in our template, in part 1 data preprocessing, remember the column was the column indexed by 0 because if you remember correctly, it was the country and it was the first column, so indexed by 0. Here, the index of our categorical variable column is the index 0, 1, 2, third index. So here, instead of 0, we're going to input 3. All right, and same for here, 3. Good. This part is the part where we use the label encoder to change the text into numbers. And we actually need to do this because we wouldn't be able to use the one-hot encoder directly on the text here because there need to be numbers to create the dummy variables. So here in one-hot encoder, we just need to replace the index. And of course, it's 3 because this is the index of the column you want to one-hot encode. Okay, and actually now it is ready. As I told you, it's very fast. We just needed to change the indexes. So let's have a final look at our matrix here because this is going to change. So let's just remember how it is. We have the state column in text. And now let's select this. Command and Control plus Enter to execute. And here we go. The encoding was successfully completed. And the cool thing is now, since all our columns are in the same type, the type of the matrix of independent variables, X is now float64. So we can have a look at X from here. So let's have a look. Double click on X. And here it is. I'm going to enlarge this and of course change the format. So as usual, I'm going to put, well, float is already here, but I'm going to choose 0 decimal. Okay, and now we clearly see that we have our 3 columns: R&D spend, administration spend, and marketing spend. And remember, before we had our 4th column, which was the state column here with the text, and this 4th column was replaced with the 3 columns here, which are the dummy variables. And remember, each column corresponds to one state. So, okay, so let's see the data set. I'm opening the data set here. So I just want to show you the first observation. So the first observation is the observation indexed by 0. So that's this one. We can check that we have the same R&D spend, 1653.49, 1653.49. Okay, so that's the same observation here. And before we had the state column here, and this observation had the New York state, and the state column was replaced by the 3 dummy variables, each dummy variable corresponding to one state. So since we have 0, 0, and 1 here, that means that this column here is the New York dummy variable column. So that's the New York dummy variable column because the state for this observation is New York, and we have a 1 here, which means that this column is New York. If we take the second observation, we can check that it's the same, 1625.98, 1625.98, okay, perfect. For this second observation, there is a 1 in the first column here, and the state is California. That means that the first column here is California. And finally, the third observation, we have a 1 in the middle here, and the state is Florida, which means that the second column is Florida. So okay, first column California, second column Florida, and third column New York. And therefore, that's how the dummy variables were created. So now I'm going to close this and this. Okay, and now just for the purpose of shaping the intuition, I'm just going to add one line here. Well, actually one new section. I'm going to call this section Avoiding the dummy variable trap. Okay, and in this section, I'm just going to write one line, which is x equals x brackets, colon, comma, and then one column. Okay, so what did I just do? I just removed the first column from x. Because by doing that, I'm taking all the lines of x, so that's fine. But then by putting this one column here, that means that I want to take all the columns of x starting from index 1 to the end. So that means that I don't take the column that has index 0, and therefore I don't take the first column. And why do I do that? Well, the answer is in the title. It's because I want to avoid the dummy variable trap. However, of course, the Python library for linear regression is taking care of the dummy variable trap, so we wouldn't need to do it manually like we do it here. But I just want to add this line to remind you about the dummy variable trap, because for some software or for some libraries, you need to take one dummy variable away manually. So this is just a reminder here. We don't have to do it here, but actually we can. We can do it here. We can select this line and execute. Then we will be sure that our dataset will not contain some redundant dependencies, because that's what the dummy variable trap is about. So we can execute this line. Let's do it. Here it is. And now, as you can see, if I go back to my matrix of independent variables x, it no longer contains the first column, which was California. But for next time, you don't need to do it manually. The library is taking care of that for you. Okay, and now we're ready to make the split. We're ready to split the data set into the training set and the test set. So as usual, we only need to maybe change the test size. So let's have a look. Our data set contains 50 observations. So what would be a good test size here? Well, 50 observations. What about putting 10 observations in a test set and 40 observations in the training set? I think this would make a good split. So actually 10 observations of 50 observation is 20%. So, okay, cool. It's already here, 20%, 0.2. So we don't have to change anything. So that's perfect. We only need to select this, press Command and Control plus Enter to execute. And here we go, perfect. Well executed. Now let's have a look at our X-train. Okay, perfect, everything seems good. It contains 40 observations. All right. Same for Y-train, 40 observations. That's the 40 observations of the dependent variable vector associated to the same 40 observations of X-train. And now X-test contains 10 observations, and same for Y-test, 10 observations. Perfect. And then we are ready because we don't need to apply feature scaling for multiple linear regression because the library will take care of that for us. So we don't have to do it manually, and therefore we are ready. Perfect. We are all good right now with the data preprocessing phase, and so we are ready to move on to the next tutorial. Thank you for watching this one, and until